Good morning. We are going to see the third problem in the centroid. First, let us go to the problem. Find the centroid of the following section. So this is the section they have given. Okay, y-axis, and here you have x-axis, and here there is a square, and there is a triangle, and there is a semicircle also. So this is the given section, and we have to find the position of the centroid with respect to y-axis and then x-axis, x bar and y bar. So these are the things we have to find. Now there is a difference in this problem to the problem we discussed in my previous classes. The first difference is, you see here, the y-axis passing at the left extreme end of the object. So this is the y-axis, no problem. This is what we have seen earlier also. But if you take the case of x-axis, this is x-axis, okay, this is x-axis, it is not passing the bottom end of the object, it is passing through the object, it is passing through the object, because below the x-axis there is a material, semicircle. Okay, so this is the first difference. Second difference is, earlier we discussed only rectangular shaped problems, but in this case you have a square, and then you have a triangle, then you have a semicircle. Okay, so this is the semicircle. These two are the differences. Now let us solve the problem. First, before going to solve the problem, you just check whether the given section is axis symmetrical or not. For that, you just go to the object again. You just cut this object into two parts by drawing y axis through middle. Okay, so this is the approximation of the middle, and this is now one part, and this is second part. Now if you see here, these two parts are not symmetrical, so this object is not symmetrical with respect to y-axis. Similarly, again you just cut this object into two by approximately drawing x-axis through the middle. Now this is one part, this is second part. You see here that these two parts are not symmetrical with each other, so this object is neither symmetrical to y-axis nor symmetrical to x-axis, so we cannot find x bar and y bar directly. In my previous video, I told that there are three steps to be followed in finding the centroid. Now let us go to the first step. It is dividing the composite section. Dividing the composite section. Okay. Now let us go to the composite section again. You see here there is a square. So this is one section, and there is a triangle, another section, and there is a semicircle, that is on another section. That's what here I have done. This is first section square, second section is a triangle, and third section is a semicircle. Make sure that when you combine these three, we have to get the final shape. That is very, very important one. And after dividing the composite section, then you have to know the centroid for these three objects. Okay, if you do not know, you have to memorize the formulas. Now I will show you the formula. First let me show you the square. Okay, so this is y-axis, this is x-axis, this is the square of side A. Now this is the centroid. Now x bar equal to a by 2 and y bar equal to again a by 2, and area is a square. Then triangle. So this is triangle. So this is y-axis, this is x-axis, HB. Now here it is b by 3, x bar is b by 3, and y bar is h by 3 of BH. This is the area. Now the third object is a semicircle. So here the formula. So this is the semicircle. Here the x-axis, here it is y-axis. Now this is nothing but x bar. X bar equal to this distance, it is r, and y bar, this is y bar, this is y bar, this is y bar, which is equal to 4r by 3 by 4r by 3 by and please note that it is referred from this x-axis. And then finally it is area by r square by 2. Okay, so you have to remember this formula, very, very important one. Now let us go to the second. First take the square. And draw a separate diagram for it. And this is a separate diagram for the square. And here it is x and here it is y. Now we will check the dimension from composite section. This side, okay, the square has 40 mm, and this side you see here a semicircle is attached, and the radius of the semicircle is 20 mm. So the diameter of the semicircle should be 40 mm. Moreover, that is the one side of the square, so this side also will have 40 mm only. Now here 40 mm, here 40 mm. This is the approximate centroid for the square x1 y1. Now x1 equal to, you know that since it is a square, it is a by 2. So that's what we have done here. X1 equal to 40 by 2, which is equal to 20 mm, and y1 which is referred from x, and again 40 by 2, which is equal to 20 mm. Then this is a square, so area is equal to 40 into 40, which is equal to 1600 mm square. Next section is the triangle. Before going to see the triangle, you have to note one very important point. Let me take a triangle, and this side is equal to b, a variable. Now this is the position of the centroid. Now from this point end, the distance is that means the distance between this point and this centroid is 2b by 3, where b is nothing but this side. If it is from line, then it is b by 3. Okay, this is very, very important thing. Please make a note of it. Now let us go to the triangle. Okay, so I'm going to draw a separate diagram for triangle, and then now just look at the composite section once again. So this is the triangle, okay, and one end of the triangle is touching the y-axis, and this is the triangle, but this triangle is not touching the x-axis. It is away from the x-axis by 40 mm. You just see here, this is the triangle. Let me draw it. Okay, so this is the triangle. It is away from x-axis by 40 mm. You have to note this one, very important parameter, or very important thing to note. Now let us draw a separate diagram. So this is the separate diagram, this is the triangle. Now this is G2, okay, approximate center, and this side you have to get the dimension. Now let us again go to the diagram. You know that this is for 40 mm and this is 70 mm. Okay, so if you subtract 40 from here, the remaining side will be 31. Now x2 equal to, so this is x2. Now you see here this is the triangle, but here the point end is in contact with y-axis. So from here to G, already we have seen here, from point end to G it is 2b by 3. Now here in the place of b you have 40 mm, so 2 into b, that means 40 by 3, which is equal to 26.66 mm. Now let us go for y2. It is the distance from this end. Now you see here, this triangle is not touching x-axis, it is away from it by the distance of 40. I have shown you here. So this is the 40, so you have to add that 40 first. You have to add that 40 plus, now this is the line end. You see here, from this line end to G it is b by 3. Okay, so here from this end, now from this line end to G it is b by 3, and in the place of b you have to take this 30, so 30 by 3, which is equal to 50 mm. Then area equal to half b by 600 mm square. Now let us go to the semicircle again. Semicircle is very important because there is a important consideration we have to do. You see here, the semicircle is, this is the x-axis and this is y-axis. So this is y-axis, but here y is minus, because this is the origin. So the semicircle should come here only. Now let us draw a separate diagram. So this is y-axis, this is the origin, this is origin, and here we have the semicircle. This is G3. Okay, this is x3 and this is y3. Please note it. It's a very important thing. Please listen carefully. Here the y3 is in the negative side because the point G3 is in the fourth quadrant, so y3 should be negative. Okay, but x3 is positive. It's a fourth quadrant, so y is in negative whereas x is positive only. Okay, so this is very important. Here y3 should be referred on negative side of the y-axis. Okay, now x3 is nothing but distance between this and this end. It is the radius of the semicircle, so 40 by 2, it is 20 mm. So here it's 20 mm. Then y3 should be taken from x-axis, and this is the diameter of the semicircle. From diameter end to this centroid, it is 4r by 3 by 4r by 3 by, and you have to put here minus because this y3 is lying on the negative side of the y-axis. 4 into r, in the place of r substitute 20, 4r by 3 by, you will get the answer as y equal to 8.48 mm. Make sure that here y3 equal to minus, then the area is equal to pi r square by 2, and you got the answer as 628.31 mm square. Now the last step, the third step is the centroid. Okay, in the place of n substitute 3. So when you expand the equation, when you expand the formula, you get the equation something like this: x1 a1 plus x2 a2 x3 a3, and this is the equation, and substitute the values, the corresponding values from this one: x120, a1 1600, and x2 equal to 26.66 mm, a2 equal to 600 mm square. When you substitute all the equation and if you do the calculation, you get the answer for x bar is equal to 21.41 mm. Similarly, you just substitute n equal to 3 and then expand the equation, you get something like this. In the place of y1 and a1, you just refer from here y1 a1 and substitute here, you will get the answer as y bar equal to 20.03 mm. Okay, so this is how we have to do the, we have to find the centroid. Thank you. We will meet in the next video.